Hey everyone, and welcome to today's Explainer. Right now, AI is completely shaking up pretty much every industry on Earth, right? But what it's doing up there in space, honestly, it's in a league of its own. I mean, pushing the boundaries of the stars means handling insane amounts of data, running systems that are mind-bogglingly complex, and making split-second decisions millions of miles from home. So today, we're going to dive into exactly how artificial intelligence is stepping up to be humanity's ultimate co-pilot.
So here is our flight plan for this explainer. We're going to start with designing the mission from ground control, then we'll check out how astronauts live alongside their new AI co-pilots. After that, we're driving in deep space, decoding the cosmos, and wrapping up with how this tech is literally powering our future.
All right, let's get right into it with Part 1, Designing the Mission, focusing on ground control and simulation.
Way before anybody even thinks about starting a countdown clock, the real magic actually happens right here on Earth. Think about it. You can't exactly just guess how much fuel you're going to need, or just cross your fingers and hope your life support holds up for a multi-year journey, right? So AI steps in to simulate all those massive mission variables. It runs through thousands and thousands of potential scenarios, figuring out the absolute best spacecraft design, tweaking the propulsion, and completely optimizing everything from energy consumption down to exactly where the cargo should go.
And this really highlights the sheer power of machine learning. The AI isn't just taking wild guesses here. It's digging through actual mountains of past mission data to predict exactly where a piece of hardware might fail. It then suggests crucial, potentially life-saving upgrades before the spacecraft even gets close to the launch pad. By learning from our past mistakes, AI drastically cuts down costs, and, far more importantly, it massively boosts our chances of a successful launch.
Okay, let's move on to Part 2, the astronaut's AI co-pilot, and look at life aboard the International Space Station.
So, as we head up into low Earth orbit, I want you to meet what might be the ultimate crewmate. One of the absolute coolest ways we're using AI right now is with virtual assistants. Take Simon, for instance. That's a system developed by the European Space Agency. Now, don't picture a basic smart speaker sitting on a desk. This is a mobile, interactive companion that actually floats around the ISS. It helps the crew manage really complex daily tasks, pulls up crucial info right when they need it, and even guides them through super complicated procedures. Plus, just by being there to interact with, it takes a huge edge off the stress and isolation that comes with long-duration missions.
And we have to remember space is an incredibly hostile environment. It throws some really severe health risks at our astronauts, stuff like cosmic radiation exposure and rapid bone density loss. To fight back against that, AI essentially steps in as a 24/7 digital doctor. It constantly crunches data coming in from wearable sensors strapped right to the astronauts, actively hunting for the earliest possible warning signs of any health issues. This means medical interventions can happen immediately, and the crew can just focus on their jobs, knowing an AI has their back.
Next up is Part 3, Driving in Deep Space, where we start navigating the unknown.
So, as we push further out into our solar system, human limitations turn into a really big roadblock. I mean, just imagine, sitting at a computer here on Earth, grabbing a joystick, and trying to dodge a Martian crater in real time. Sounds like a fun video game, right? But out there in the real world, it is literally impossible thanks to the laws of physics and the sheer distances we're talking about. We're talking about a 13 to 24-minute delay just to get one single signal from Earth all the way to Mars. Think about that for a second. If a multi-million-dollar rover is driving straight toward a cliff, the human operators back at NASA wouldn't even see the danger until up to 24 minutes after it happened. And then it's another 24 minutes just to send the command to hit the brakes. So yeah, real-time remote control, entirely impractical.
So, how do we solve this? Well, NASA relies on AI to autonomously navigate the Martian terrain. Rovers like Curiosity are packed with sophisticated algorithms that let them make split-second, life-or-death decisions completely on their own. Curiosity analyzes the dirt in front of it, picks out interesting scientific targets, and, most importantly, steers itself away from hazardous rocks and steep drops. It doesn't sit around waiting for human permission to move, which makes these missions infinitely more efficient.
Which brings us to Part 4, Decoding the Cosmos, as we look at how AI is processing the universe. Once we look past our own solar system, the sheer, staggering volume of information becomes the next big hurdle. Human researchers simply cannot keep up with the cosmos anymore. I mean, we're talking about an absolute flood of data pouring in from satellites and space telescopes. It is way, way more than any human team could ever sift through manually. Traditional data analysis completely breaks down at this scale, but AI?
Machine learning models absolutely thrive on this stuff. They can chew through these massive data sets in no time, easily spotting anomalies and subtle cosmic patterns that human eyes would definitely miss.
A perfect example of this is NASA's James Webb Space Telescope. It's looking into the deepest, oldest parts of the universe, and it relies on these exact AI algorithms to make sense of the incoming data. Machine learning is actively out there right now, pinpointing new exoplanets, figuring out the chemical composition of distant galaxies, and even hunting for potential signs of life. It's also watching the skies for these super rare, fleeting events like supernovae and gamma-ray bursts. Basically, AI is putting the pace of human discovery into overdrive.
And finally, Part 5, powering our future and getting energy from the stars. You see, reaching out into the deepest parts of the universe actually brings some incredible value right back home to us. If humanity is ever going to set up permanent bases on other planets, we obviously can't pack everything we need in the trunk. We have to live off the land. AI is going to be absolutely essential here, scanning planetary surfaces to identify the valuable resources we'll need for future human colonization. But it goes beyond just finding space water and space minerals. AI is paving the way for space-based infrastructure that can benefit us today.
Just look at our energy needs. Down here on Earth, solar power is great, but it's constantly interrupted by weather, the atmosphere, and, well, nighttime. Space-based solar power, on the other hand, wouldn't have any of those issues. It could run continuously. But managing a massive solar array in orbit and beaming that power back down, that is a total logistical nightmare. That's where AI steps up. Algorithms can optimize exactly where those solar panels sit, monitor the energy generation in real time, and manage the incredibly complex transmission of that power back to Earth. This AI-optimized setup could give us a 24/7 source of clean energy, literally helping to solve Earth's energy crisis.
So as we've seen throughout this explainer, AI is touching absolutely everything in space exploration. From tweaking spacecraft designs and keeping astronauts healthy, to driving rovers across Mars and decoding the secrets of distant galaxies. It's not replacing us out there, it's the exact technology we need to survive and thrive among the stars. So knowing we have this incredibly powerful artificial intelligence acting as our ever-vigilant co-pilot, the only question left is just how far into the universe will humanity reach next? Thanks for joining me on this explainer, and keep looking up.